So welcome back to Chem Prep Hub. We are back with another question. So this question, based on de Broglie wavelength, was asked in JAM 2025 chemistry examination. It's a question of JAM 2025. Okay. It's basically a numerical answer type question. Okay. So it says an electron at rest is accelerated through 10 kilovolts potential. The potential energy is given to you. It directly asks the de Broglie wavelength and angstrom of the electron. We'll see how it is derived. Okay. And also we'll look at the numerical calculations. The values are provided to you. Mass of electron is given. Value of Planck's constant is given. So let's go. Okay. So when you basically accelerate an electron, when you accelerate an electron through a high potential energy, by providing a high potential energy, okay, so electric potential energy the electric potential energy is basically stored. The electric potential energy that is stored is given by the charge, that is here electronic charge, multiplied by the voltage, that is E multiplied by V. And since this electric potential energy, or you can say this energy, is used to accelerate the electron, this energy is used to accelerate the electron, so this is kind of converted to the kinetic energy of the electron, because this same energy is used to accelerate the electron. So basically you can say the loss in potential energy, the loss in potential energy, okay, loss in the potential energy of the electron is equal to gain in its kinetic energy, gain in its kinetic energy. So these two forces will be, or we can say these two energies will be balancing each other. Now we know what is the kinetic energy of the electron. Half multiplied by mass of the electron multiplied by square of the velocity. Okay, multiplied by square of the velocity. And this will be equal to the electric potential energy that was stored initially, that we uh, solved as E times of V. Okay, that is the electronic charge multiplied by the voltage. So this, let us write it as VE. Otherwise, you will confuse it with this V. This V is the potential. This V is the potential, and this VE is the velocity of the electron. This V is the velocity of the electron. So now, basically, if you write it as the equation form, MEV square is equal to twice of EV, right? MEV square is equal to twice of EV. Now you just, I'm trying to bring it into a particular form, so you'll realize it later. So you multiply mass on both the sides, so you get ME square V square is equal to 2ME into EV. I have just multiplied mass on both the sides, and hence MEVE whole square is equal to twice of MEEV, which gives you MEVE is equal to whole square root of twice of mass of the electron multiplied by electronic charge multiplied by the voltage. Now we know that the de Broglie wavelength, here we have been asked about the de Broglie wavelength in angstrom. You know that using this relation you can write de Broglie wavelength lambda is equal to h by p. P is the momentum, or we can say h by momentum is equal to mass multiplied by the velocity, which is equal to h by square root of twice of EV. Okay, so this is the relation. So what is the final relation? Final relation that we have just derived will be, just a minute. Okay. So the final relation from this will be lambda is equal to h by MeVE, that is the momentum, which is equal to h by square root of 2 times of Me times of V. So this is how it varies with the voltage. Now, if you look at the question now, the question says the electron at rest is accelerated through this much potential. So now you know that the relation you know now, you have derived the relation. So you have been given everything else, you have to just put the values. Lambda is equal to, h by square root twice of Me into Ev, that is equal to, value of h is given to you 6.63 into 10 to the power minus 34 joules second, and you just divide it by twice of mass of the electron, that is this much kilograms, multiplied by the electronic charge, that is 1.6 into 10 to the power minus 19, multiplied by the voltage, that is 10 to the power 4 volts. Okay, that is 10 to the power 4 volts. So you just need to solve this. So the thing that you are going to get is basically, I have calculated it. So you are going to get 6.63 multiplied by 10 to the power minus 34 divided by square root of 29.152 multiplied by 10 to the power minus 46. So you know that square root means whole to the power 1 by 2 minus 1 by 2. So this will be half, and you take the square root of the other number. So you are going to get it as, yeah, 5.3992 multiplied by 10 to the power minus 23. So lambda will be equal to, approximately you will be getting, yeah, 0.1228 multiplied by 10 to the power minus 10 meters. And the question here says that you need to mention it in angstrom, the de Broglie wavelength in angstrom. So this is exactly what in angstrom you are going to get, 10 to the power minus 10. So lambda is approximately coming out to be 0.122 also you can write angstrom, or it's a numerical answer type. It has been provided in the question that you need to answer up to 3 decimal places. So you need to also write as, you can also write it as almost equal to 0.123 angstrom as well if you're rounding it off, because 1228 is almost rounded off to 0.123 also. There's a very wide range for such questions. Okay, so you don't need to worry about that. If you solve properly, you will get it in the desired range. So this is what it is. So I hope you have understood this particular derivation and this particular question. So that's it for this video. Subscribe to the channel for more. I'll keep posting questions like this, and keep sharing your feedback. Thank you. Meet you in the next video.